All right, welcome back. This time I'll kind of be talking instead of arrays and pointers. We're going to talk about some constants versus variables, preprocessor, and compile time versus runtime. So you get a sense of what your variables are actually doing before we get more in depth into them. So right here we have int a. That's a variable that we've declared right there. So basically, a is stored in memory. We can type a later. So we do like int b equals a plus something. We can refer to that memory location, and whatever's stored in it, whether it's 16 or whether we say right here, a equals a plus 1, and then it adds 1 to it. It'll grab it wherever, so we can use it like that. We can also use numbers just about anywhere the same way that we would use them. So instead of saying like right here a plus 1, I could say 16 plus 1, and it'll do the same thing. For the most part though, things like this, 16 plus 1, if it can be handled by the compiler, it'll go ahead and do that. And then there are some things that the compiler will want to handle that you can't use variables for. You have to use a constant. So say I want to make an array of 20 integers, and I'll just say 20 right here, and then I'll go ahead and initialize it as like 1 and 2 and 3 and so on. So right there I can easily do that. But if I wanted to say give me an array that's, I'll call it a different thing, numbers 2, that's a long, and try to use that, it's not going to work. It's going to tell me that if it wants to grab some spot out of memory, out of the automatically allocated memory, we're going to need a literal right here. So we can't do crazy stuff, but we can always allocate pointer memory and stuff like that. So it's not that big a deal, but we'll get to the ways around that later. For now, just realize that the preprocessor will go through and compile our code, or the compiler will go through and process our code and turn it into a program. And so some things like this have to be like that because of how it gets compiled. And then some things like this can be simplified by the compiler so that our computer, while it's running the code, isn't doing unnecessary things. Compiler will really take care of a lot of stuff for us. It's kind of crazy like that. For integers, a literal is just a decimal number like this. You can also give it things like OX, whatever will be the hex version. So you do like A2F, and then like that's a hex number right there. So A is actually a 10, and F is like a 15 or something, and 2 is a 2. So you can use literals like this. You can also use binary literals, which I think you just say like B, maybe it's 0B, and then you can do 1s and 0s. I don't know. You'll have to look into those. Google it. But you can give integer literals like this. A character literal is just anything in between these two quotes, so like an A or a C or a 2. That's the character 2, not the number 2. Strings are inside double quotes, so it's all like that. And now anytime we have a function or something that wants a string or it wants a character or a number, you can pass it either a variable or you can pass it a constant, and it'll use the constant as if it was a variable. It'll actually assign it to that parameter inside the function. Let's see what else. Oh yeah, defined constants. So this is all inside your main right here. You can assign things to variables. But say I want to use something like pi, right? I want to keep using that over and over. So I'll say something like area equals blah 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 with pi, 2 times something and pi and all that, right? So if I don't want pi to be a variable, or I don't want to set it to something constant here, we can say define pi 3.14. And actually, if you include the math header, it'll have pi and a bunch of other constants already defined for you. But basically, if you use pi anywhere down here, when you compile your program, the preprocessor will look for anything called pi, and it'll go ahead and put 3.14 in its spot instead of pi. So this define thing, you can define just about anything as something else and then use it later. You can define like A as the character A. So anytime you just type A somewhere down here, now it would screw up your code right here because it would replace this with a character A, and then it would try to assign a literal to a literal that you've called an int, and it would jack things all up. So that's no good. You can also define other things like macros. So you could say, min of like x and y, and then define that as an actual little function that will evaluate this for you whenever it comes across it. Whoops, how am I doing? And then we'll use like conditional operator, and then if we get the right thing, we'll go x, and if we get the other one, we'll return y, and so it should return, oh, I think I did max there. So this should, anytime it finds down here, something like min of a, comma, like 17, it'll give us Boolean or whatever value. It'll basically replace that with this right here. It'll say a less than 16, and then it'll ask if it is, then return a, else return 16. So yeah, those are useful, but you probably won't use macros really ever. Let's see what else. Compile and runtime. Yeah, I don't know. I'll go